The next section of the lesson is going to look at the blood vessels. We've touched on this, but let's look at them in a little bit more detail and get more of an understanding about what's going on when we talk about the different types of blood vessels that are in our body. Obviously, all these vessels are like a transport network for the blood as it travels around the body. So let's look at how this works. Now, you can remember that there are three main types of blood vessels. These are the ones that we need to know in GCSE PE, and these are the ways that the blood is transported around the body. But let's look a little bit closer at these: arteries, veins and capillaries. So the key terms, some key terms that we need to know. Quick recap: arteries, blood vessels that carry blood away from the heart to the muscles to the other organs. Then we have next to it the capillaries. These are blood vessels that wrap around the muscles and the organs so that gaseous exchange can take place. We'll look at this a little bit more detail when we go on to the following slides. And veins are the blood vessels that carry blood from the muscles and organs back to the heart, thus closing that loop. What else do we need to know? Well, if you look down to the bottom left side, we have just down here at the bottom, we have got lumen. Now, lumen is another name for the internal diameter of a blood vessel, because obviously we need to be able to talk about what happens to the diameter of a blood vessel during different stages of exercise. We've already referred to the temperature of the body and how the blood vessels may react to that. So for now, key term is lumen, the internal diameter of a blood vessel. Up in the top right, we've got deoxygenated blood. Now remember, this is not blood that has no oxygen in it. There is a low concentration of oxygen. When we talk about deoxygenated blood, we're just talking about a low concentration of oxygen. And if that comes up in an exam question, that's the way to describe that. It has a low concentration of oxygen. Whereas oxygenated blood, on the other hand, has a high concentration of oxygen. Pretty easy to get your head around. Okay, so what I was saying is the diameter of a blood vessel. As you can see here, I put an arrow in. We're looking straight at a blood vessel. We can see that there's a wide gap in the middle. That is where the blood flows down. So that's the channel the blood flows through. Another thing to point out here is we have this layer inside here of a blood vessel. Now, blood vessels also have muscles. So there's a muscular wall that's in a blood vessel, and that is, muscles can contract, can relax, and therefore change the diameter of that blood vessel, so change the lumen of the blood vessel. So something we need to be aware of as we move forward in the lesson. So let's take a closer look now at the three different types of blood vessels that we need to know in GCSE PE. And as you can see here, we've got an artery. So just looking up here in the top left hand corner, this is an artery. What can we say about an artery then, and how is it different really from the other blood vessels? Well, an artery has a thick outer wall. So you can see, if you just look at the top left, this little area in here is quite thick. Okay, so this area here is the outer wall and is quite thick. Also, we'll also notice that it has a thick layer of muscle. So this layer in here is a layer of muscle. Now this is different if we look over at a vein on the other side. It has a fairly thin outer wall and a thin layer of muscle. Both of these are quite elastic. That just means that they can stretch out and stretch back in. And that is something to be aware of when we're talking about blood vessels. Let's just look over at a vein then, now that we know what an artery is. Let's look at the vein. Now the vein has a very large lumen as opposed to the artery. So you look back over at the artery, you can see that the artery in the center bit, this bit here, has quite a, I don't know why my pen's not really showing up on that, but it's got a small lumen compared to the vein on the other side. So they're the key differences between a vein and an artery, and then we look down to a capillary. Now obviously this isn't done to scale because capillaries are one cell thick, very, very, very small microscopic blood vessels these are, and so obviously it's got a very small lumen, and then the wall is made of a single layer of a cell. Now it does that for a reason, because the outer layer of the capillary is so thin, it enables those oxygen molecules to diffuse through the walls of that and into the muscle, and the carbon dioxide obviously to come out of the muscle and into the capillary, and then therefore that turns the blood around the capillaries from an area of high oxygen, blood with a concentration of high oxygen I should say, to blood with a concentration of low oxygen, and then the veins can do its job and take that blood back up to the heart, then to the lungs to get that oxygen into the blood again and start the process. So this is cross sections of artery, vein and capillary, some real key things that you need to know here. So get your head around that and we'll move on again. One thing that we didn't mention were veins. Now veins have valves, quite easy to remember because they both begin with the letter V. Now, as you can see in this little image that I've put in here, the blood is flowing upwards and it is passing through this thing in the middle here, which is a valve. Now valves, the beauty of valves is they'll let the blood flow through one direction, but they prevent it flowing back the other direction. So you can see when that arrow at the top is trying to come back down, the valve is stopping that from going through the opening again. So real key point here, veins have valves. What do valves do? They stop the backflow of blood. We want to keep that blood flowing in the same direction, particularly if that blood is moving from the lower body back up to the heart. Obviously it's going against gravity as well, and it's got to use that force and these valves to keep that blood circulating back up to the heart without it going backwards. So that's why we need veins. Very important. So let's just recap for a second on the difference between arteries and veins. Now arteries have signified or put a symbol in here of red because that's how it will show up in most of the images and the diagrams that you might be given in a GCSE type question. So what do we know about arteries? They take blood away from the heart. How do we remember that? Arteries begins with A, the word away begins with A, and that's the connection that we need to make. What about its walls? The walls are thick and elastic, so stretchy. Transports oxygenated blood. That is true except for the pulmonary artery. That's the only exception to that. The pulmonary artery obviously takes blood away because it's an artery from the heart, but that artery is going up to the lungs where it's going to pick up that oxygen. So yes, arteries transport oxygenated blood, but bear in mind the exception, the one exception of the pulmonary artery. What else do we know? Well, the lumen, which is the diameter of the blood vessel, is small in an artery. An artery has a pulse and blood travels in spurts. Now, blood travels at high speeds in arteries. Arteries, slightly different from the veins, they have no valves, usually to do with the high blood pressure that's in there. They don't need valves. And during exercise, the arteries dilate, which just means they widen. Let's look at veins on the other side. They take blood to the heart. The walls are thin. Transport deoxygenated blood. As I said before, there is an exception to that one. The pulmonary vein that is going back to the heart has deoxygenated blood because it's just come from the lungs. It just picked up all that nice oxygen that it needs, and it's gone back to the heart to then be squeezed out to those muscles and other areas of the body. Vein has a large lumen. It has a larger diameter cross section when you look at it when compared to an artery, and it has no pulse and blood travels smoothly through it, and it does have valves, and the valves are there, as you know, for the reason to stop backflow of blood. So quite a few bullet points there. Not very difficult to get your head around that, but it's very important that we know the difference between arteries and veins as we move through this course. So we can't really talk about the heart, the blood vessels, the blood, without mentioning blood pressure. So a lot of people have a misunderstanding of what blood pressure means, but if we just simplify it down to mean it's the pressure of the blood against the walls of the blood vessels, and especially the arteries, because that's the delivery of that oxygenated blood to the muscle system. So blood pressure, pressure of blood against the walls of the blood vessels. And some people have low blood pressure, some people have high blood pressure, and we can think about the reasons for that as well. Now, when you think of a heart and you think of a heartbeat, you think of two beats. It beats twice. Boom, boom, boom. Now, the reason that does that, we're going to look at now. There are two phases of a heart acting as a pump. When the heart squeezes and it contracts and squeezes out that blood from the left ventricle, that is one of the sounds or one of the phases of the heartbeat, and we call that systole. So we call that phase systole. Some people pronounce it as systole. Doesn't matter, as long as you're confident with the spelling and confident with answering that and being able to recognize that in the contracting or squeezing phase we call that systole. So what's the other one? Well, you can probably guess already. One's the contracting squeezing phase, but when the heart relaxes and it refills back up with blood, this is called diastole or diastole. I like to call it diastole. That's what I taught in the lessons, so I'm just going to go with that. This is the relaxing phase of the heartbeat, when it fills back up with the blood, ready to be squeezed out again to those organs, to those muscles in the body. And you can see over on the right hand side, we can see an artery, all the characteristics that we just talked about, and also depicts the journey that blood is going to take around the body. Again, just to reinforce what blood pressure is, it is the pressure on the arteries, on those blood vessels. So the pressure of the blood, I should say, on the walls of the blood vessels. And in particular, we always pay particular attention to the arteries. If you don't want high blood pressure, it can be risky. Now in GCSE PE, we often make connections about different topics that we've covered. So if we think back now to when you did the topic on healthy active lifestyles or sedentary lifestyles, think back to the topic that we did on diet and all the knowledge that we have from diet. It starts to get us to think about things that we do in our life that can affect our blood vessels and therefore the delivery system, the cardiovascular delivery system. Now the first one, as you can see, is if you do have a diet and a poor diet and you're inactive, this can lead to a build-up of fatty deposits on the inside of the veins and arteries. Obviously we don't want that. That sounds bad. It is bad. So if you're spending all your time in Shalimar eating fatty food and fried food, you are putting yourself at risk here of developing those fatty deposits on the inside of your arteries and veins. What happens then? Well, because of that, this makes it difficult for blood to flow through. You are putting something on the inside of your blood vessels, and obviously we want to keep that channel as wide as possible. So we need to think about how active we are, but also we need to think about what type of food are we putting in our body and what potential damage that food is doing to our arteries. If we look down at number 3, so in cases where this becomes really bad, say somebody's had a diet extremely high in saturated fat for a long period of time, this can cause that fatty deposit to build up so much that they totally block that blood vessel, and this is the cause of heart attacks. And we know heart attacks are very, very serious and can be fatal, So we want to avoid that at all costs. So how do we avoid it? Look at number 4. Long-term exercise prevents this build-up in the arteries and veins and helps them remain clear and healthy. So that is why everybody, including all PE teachers and all teachers in the school, would reinforce having a healthy, active lifestyle, and also eating a balanced diet that's not too high in saturated fat that can build up this fatty deposits on the inside of your veins and arteries. So you may have had your blood pressure taken before, and it looks something like this picture that we can see here with the arm, and you got the blood pressure monitor that is connected, and the doctor usually hits a button and it inflates, or they squeeze something and you feel it getting tight around your arm. And what this is actually doing is it's measuring the pressure on the arteries during the squeezing phase. As you can see on the sheet here, you can see systole, the squeezing phase, the top figure 131 in this instance, and then you've got the next reading, which is diastole, so you can see over 76. So this is the pressure during the squeezing phase as opposed to the relaxation phase. Now obviously the squeezing phase, the blood pressure is going to be quite higher, in fact, and that is the reading that we get. Now this section over here, we can see anytime you're presented with something like this, where you got a figure or a graph, just think to yourself, what's the x-axis telling me, what's the y-axis telling me, and what can I take from this? So if we look at the x-axis first of all, down the bottom, we all know that the x-axis, hopefully we all know at this stage, the x-axis is along the bottom. Let me just put an X there. And we also know that the y-axis is the one that runs up vertically. Now you can see two readings. On the x-axis, diastolic blood pressure, so that's the bottom number, and we can see that the y-axis is systolic blood pressure, so the blood pressure when the heart is squeezing and contracting. So let's look at this. Okay, so this fella here looks like he's got 131 for his systolic and 76 for his diastolic. Now if we were to draw a point in here, this is a potential question which you might get in a GCSE paper. So let's just look at this. 131, so just up there. How far across am I going? Over 76, which would be around about here. So if I just put a little dot in there, try and get it as accurate as I can. So if we look here, well, what's that telling us? That's telling us that this person down here is in this zone of yellow. What's the yellow telling us? Well, the doctor's going to tell this person that, you know what, you've got pre-high blood pressure. So alarm bells are not going off yet, because we're not saying that your high blood pressure, your blood pressure is high. It's not in the red zone yet, but I tell you what, you need to be taking some action to reduce your blood pressure. Maybe it's your diet, maybe it's a little bit more exercise, a bit more of an active lifestyle, because really what you want to do is somehow drop that reading that this person has down into that green phase. So this is the ideal, this is the sweet spot, is this green phase here. So you want your blood pressure to be somewhere around there. Too low, obviously it could be a problem. If you haven't got enough pressure in your arteries to get that blood around your body, it can also be a problem. So you want it to be in that green zone.